All right, everybody, before we can advance in our thermal energy investigation of the fancy cup and the regular cup, we need to spend a little time learning some background information about thermal energy and how energy can transfer from one place to another. So for assignment 1 this week, we are going to be doing some reading on thermal energy transfer. The key concepts that we're going to be focusing on are: what is the effect of having a small specific heat? So you're going to be learning about how different objects take a different amount of energy to heat up. What happens to the material when it's heated? So when we heat something up, does anything actually happen to the material? And then lastly, in what ways can thermal energy be transferred? And this part is really going to help us build our understanding of why the temperature is changing in our cup when it's exposed to the air, and what is actually causing that, and how does that happen. So before you do the reading today, we're going to be doing some marking of the text. Start by filling out the before you read box. And these are just statements of what you think before and what you think after. So for the first statement, it says, it takes a large amount of energy to significantly change the temperature of an object with a low specific heat. So do you agree with that, or do you disagree with that? So you're going to put in each box A if you agree. So before, if you agree, you would put A, or a D if you disagree. After you read it, you come back and you put in what you think now. So maybe you agree with that still after you read that. The first thing we do when we marker the text, we've done this in class, is we number our paragraphs, and that's just going to help you so you can refer to the reading when we talk about it in class. So this is our first paragraph. It's going to be paragraph 1. It's going to be paragraph 2. It's going to be paragraph 3. And 4. 5. Paragraph 6. 7. 8, 9, 10, 11, 12, 13, 14, 15, 16, and paragraph 17. So the first thing we do when we mark the text, we'll do an example here together. Let's start by reading the first paragraph here that talks about radiation. So I'm going to go ahead and read it. It says, the transfer of thermal energy from one material to another by electromagnetic waves is called radiation. All matter, including the sun, fire, you, and even ice, transfers thermal energy by radiation. Warm objects emit more radiation than cold objects do. You feel the transfer of thermal energy by radiation less when you place your hands near a block of ice than when you place your hands near a fire. Okay, so in that paragraph is all about radiation. So the first thing we do when we mark the text is we circle the keywords, and they've done a lot of the work for you because they've actually highlighted some of those keywords. So one of our keywords is radiation. And we're going to circle those highlighted words. We're going to circle words that appear over and over in the text. Another thing that we're going to circle is thermal energy, because that appears in the text a few times. So you can also see we have thermal energy right here again. So the next thing we're going to do is we're going to underline facts, evidence, definitions, supporting information that helps us figure out our purpose for reading. And our purpose for reading today is to get a better understanding of how thermal energy can transfer from one place to another. What are those different processes and how does that happen? So right away, we have a definition for radiation. And it says the transfer of thermal energy from one material to another by electromagnetic waves is called radiation. So we're going to underline this first sentence right here because that's a definition. We also, it says, example, all matter, including sun, fire, you, and even ice, transfers thermal energy by radiation. It says warm objects emit more radiation than cold objects. So that might be an example. We might want to underline that. because it's talking about some evidence that warm objects would typically give off more radiation than cold objects. So that's about all we're going to circle and underline in that first paragraph. So remember, the first thing you do is you circle keywords, and those are the bold words, and then you're going to underline the supporting evidence, facts, and definitions. The goal is not to underline and circle everything in the paragraph. After you guys finish the marking of the text, there's a few questions on the margin here that I'd like you to do. So number one, it's talking about what is radiation. So you can find that straight from paragraph 2. You actually circled it and you underlined it. The next one is going to be number 2. It says, think it over. Predict. Suppose you have a cup of hot tea outside on a cold day. What will happen? Circle the correct answer. So you have to think about, if this hot tea was just sitting outside, what do you think would happen to the particles in the tea? Okay, so look at your options and think carefully about that one. Number 3, reading check, says contrast. What is the difference between a thermal conductor and a thermal insulator? So part of what you're going to be reading about is thermal conductors and insulators, and you're going to learn about how some things transfer heat really well and other materials kind of trap heat and don't transfer heat. So you're going to be learning about the difference between a conductor and an insulator. This is going to help us when we design our own thermos cup later in this unit. Number 4 says, define what is specific heat. So you're reading about specific heat in this paragraph, and you're going to learn that specific heat is basically how much energy it takes to heat up something by 1 degree Celsius. Okay, so you're going to be reading about what that is and how different materials have different specific heats. Number 5 says, summarize. What does it mean if a material has a low specific heat? So you're going to be reading about different examples in a car, different materials, and what kinds of specific heat that it has. So what does it actually tell us about something if it has a low specific heat? Number 6 says, analyze. Which item in the car requires more thermal energy to change its temperature by 1 degree Celsius? The metal belt buckle or the cloth seat back? Think about when you've been in a car after it's been sitting in the sun for a long time. What is that hottest object in the car? You've probably experienced this in your life where you've touched something in the car and it's kind of felt really hot, and other things in the car haven't. And then the last 2 questions here are number 7 and 8. It says, explain what happens to the volume of a gas when it's heated. So you want to read about thermal expansion and contraction to help you answer number 7. And then number 8 says, think it over, evaluate. Thermal expansion is most noticeable in what? So you're thinking about what type of matter are you going to be having the matter expand the most when it's heated up? Is it going to be in a liquid, a solid, or a gas? And then number 9 says, what process occurs in a sidewalk when the temperature decreases? So what is it called when maybe the winter comes and the sidewalk cools down? What process is that called? What's going to happen to that sidewalk? So that's been a quick preview of assignment number 1. So you're going to have Monday and Tuesday to work on this. One hint of advice, if you need some help with the reading, you can use the ebook like we've talked about, and you can go to the section in your book called Thermal Energy Transfers, and you can actually have the book read this to you, and you can highlight it as you go through it. So if you have any questions, send me a message in Schoology. Have a great day today.